If you're going to make a client application for a WebSocket API, you will probably find that this is very difficult. And why is it so difficult to make a client application for a WebSocket API when a REST API can be so easy? So one of the primary reasons is the control flow. So this is the documentation for the React use WebSocket hook. And that is a wrapper that is built on top of the browser's native WebSocket client. So what it does is that it sends data to a WebSocket server, and then it also, of course, listens to messages coming from the WebSocket server. So when you actually run the program, this is what you'll get. You'll get the possibility of being able to send messages to a server, and then you'll get the data back again. But the confusing thing is, this here is the point at which you're sending the data. This is the button handler. But the button handler here, in no way can you actually get the response inside of the button handler here without doing some weird kung fu stuff. So if you say const result equals send message, this here doesn't make sense because the send message method here is actually a void. And that means the data coming in from the API is actually coming in up here. So what do we do now? Well, you might have some kind of tangible feature where you're signing in, and then you're subscribing to some kind of topic, and then you are broadcasting some data to other clients. So how would you do that? Well, maybe you would click a button here in order to sign in, and then somewhere inside of the use effect hook, you need to figure out if the data that you get from the API now is a valid sign-in, and then you would do something else. But one solution to this problem is, why don't we just make a REST API on the side? Then we can use the WebSocket API to listen to things here, but then we use a request response pattern with a typical REST API to do things like signing in and tangible actions that require responses. But then you'd have to maintain two separate APIs, and maybe there's a bunch of problems associated with doing that as well. So I have a different antidote to this problem. I want to open up the package JSON file here. So this is the name of my solution here for it. It's called WebSocket request hook. And the usage is that you need to take your application. So here I was just demonstrating, the good old React use WebSocket hook. I'm going to remove that one, remove the import, uncomment this one, and then add the import here from the WebSocket request hook. And then you basically just have your entire application within the WebSocket client provider. So here is an example of a component that is using the use WebSocket client. This here is the hook that we need to use when you communicate with our API. Every single time we use it, we will always use the exact same connection going to this WebSocket API here. If you declare another address here, you will be using a different WebSocket API all over the place. That also means, like, if you want to test something, and inside of your testing, you might have some kind of component here that you want to test, but you want to test it with a particular staging API or something. Then that's very handy. But inside of a component, you will always be using this use WebSocket client. And there's going to be three variables that are exposed. There is the ready state. This just gives you a number depending on the state of the WebSocket connection. And then there is the on message, which is used to listen for particular events. And then there is the send request, which is used for sending data to the API. So let's talk about this send request function here. In order to send a request, you must denote what is the object you're sending, what type is it, and then what type are you expecting to be returned under the successful circumstance. And then you have the parameters, and inside of the parameters you have two arguments. The first one is the actual object you're sending and not just the type. And then the second is actually just a string, and the string denotes the successful response type. Okay, so notice that I have this thing called event type here. Event type must be declared. When you're sending something to the API, you must indicate towards the API, what am I actually trying to do here as a client? In this instance, the client is trying to sign in. That's a particular event. So we're attaching this to the object. Inside of the browser, this is what it looks like. Click the sign in here, and then it will say that the event type here is client wants to sign in. And then, of course, there is a response here. And the response also has an event type, and that is server authenticates client. And now this is the interesting thing. The response here is condensed within this variable here. This is the response from the API. We can take the response from the API, and they will just have it in the same line as we're sending the request. So this is very much the same way you're doing things with a normal HTTP REST API, and you're using a client like a Fetch or like Axios, sending a request, and then you're getting a response, and then you can read the response. And the way that this is possible is because the framework behind the scenes will send a request ID. And then once the response attaches the same request ID, the framework will know, oh, here is the response for the request that we sent. And we're expecting the response to be this particular type here. So I'll just show you where I define my types. I have a file here where I just define some types like server authenticates client and client wants to broadcast a topic. Everything should extend base DTO, which makes it contain a request ID and an event type. And then inside of the usage here, I wrap it inside of a try-catch block. So the way it works is you tell the little function here, what do I expect to get back? So this is actually just a constant that I have somewhere that is just a string. So basically, this is equivalent. So you could also just hard-code a string here. This is effectively the same that will happen. And the idea is that if the function here sees that the request ID is not of this type, it will just throw us into the catch block here. So this way, you can make sure that anything here is success. And if you get into this block, it means you either didn't get a response back when you sent the request ID, or the response that you got back is not the expected type. Okay, so there's a different event type. The event that occurred was different from what was expected. So what I like to do is actually make a type for the error. So right here I have something called server sends error message. I would just write const error DTO equals error as unknown as a server sends error message. And then you can log this one, for instance, or do something else. So let's try and produce an error. So I have hard-coded on the API that if you use this one and you try to sign in with this particular one, it will just give you an error back. So if we try to open up here, go to the console, and you click sign in here, this is coming from the catch block now. And like I mentioned before, we have other variables here. And we're going to look at the on message that is used for listening for events that don't require a request first now. So we have this function here called React broadcast here. It uses the on message, and on message requires a string indicating the event type. So that is simply this string here inside of the JSON. If there is the event type server broadcast message here, this is the one that I'm indicating that I'm more listening for. This is just a string that I'm looking up. Then I will get into this block here. So this is a way of simply saying, do this action when this thing occurs, and we don't need to send something from this component before that happens. So this way you can have a lot of different components using the same WebSocket connection, but only reacting to what it itself cares about.